All right, hey guys, I'm going to go over now a related rates problem dealing with a sliding ladder. Isn't that right? Yeah, that's right, guys. This is pretty common, maybe not common, but it's a it's a traditional related rates problem. Well, let's read it through. We've got a 10-foot ladder that's resting along a vertical wall. At the bottom of the ladder slides away from the wall at a rate of 1 foot per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Now, don't try to do this in your head. And it sounds sometimes the answer will be easy, but it's not what you would probably initially think. So let's just draw this first. So in other words, sometimes you would think like, oh, is it 1 foot per second? It's 1 foot per second too, but it's not. So let's draw a wall, and this wall will look like a vertical line. That's a pretty good wall. What we're gonna do is we're also gonna draw a floor. Yeah. We're gonna make these our axes. We'll make this a y-axis, x-axis. Then we're gonna draw a ladder. Bang, that's a pretty good ladder. Ladder goes from here to here. So this is our 10-foot ladder. Now, this ladder always stays 10 feet, and if it's on a vertical wall, that means it's gonna have a right angle here. So you can look at this wall as it being the I forgot the vertical side of a right triangle, and you can look at the floor, the distance from the wall. Let's call this the wall. Wall. Well, no, this whole thing's the wall. Let's make it like thick, I guess. I don't know if that did anything, but anyways, so this distance will change because as the ladder is sliding down, the height that it's above the ground is going to get shorter and shorter, and then this distance will increase. So but the ladder distance, the red length stays the same. So let's look at this part. It says when the bottom of the ladder is 6 feet from the wall. So this distance will be 6 feet. Now, this distance is going to be a variable. We'll call it x, just to make it simple. This will be our x. The length from here to here is x. Maybe I'll just do that actually. And the length from here to here is going to be y. Okay, so this height is y. This width, or the distance from the ladder to the wall, is x. Now, x and y are changing. So it doesn't start at 6. It's going to be sliding down this wall at a rate of 1 foot per second. So this is y. So then we say dy dt would essentially be like this motion. Now let me draw it actually out here. Think of dy dt as being this wall or this length changing. And then dx dt would be this length expanding. Okay, because these are changing. The way this length changes is in terms of x, and the way this length changes is in terms of y, and it's getting shorter, this is getting longer. Now, they're all related by the popular equation, x squared plus y squared equals 10 squared. Okay? Now, essentially, we want to find how fast is the top of the ladder. So what is dy dt? Find dy dt when x equals 6. Okay, and I don't know if I said this was 1 foot per second, but I guess I mean this because it says it's sliding away from the wall at a rate of 1 foot per second. Man, I wish I didn't write this so wide. But anyways, find dy dt when x is 6. We're given that dx dt is 1 foot per second. So dx dt is just 1 foot. Okay. 1 foot per second, I guess. Be more specific. Now, what we want to do is use this equation to find these values. Let's find dy dt. So let's differentiate these because remember, x and y are technically functions of t. So you can look at this as x of t squared plus y of t squared equals 100. If you want to understand it more clearly, so using the chain rule, this will be 2x. Differentiating this will be 2x dx dt plus 2y dy dt equals 0. So now we just have to solve this because we're given 1 for dx dt and we're given 6 for x. So this just becomes 2 times 6 times 1 plus 2y dy dt equal to 0. But let's find out what y would be. And we can do that by plugging in 6 for x and solving for y. So, because when x is 6, you'll have 6 squared plus y squared equals 100. So then y squared will be 64, so y will be 8. So all we do is put an 8 there. So we have 2 times 6, we have 12, plus 2 times 8 times dy dt. So we have, let's take away 12. So here we have 16 dy dt. Can you all see that? Hey guys. I didn't think I needed so much work. Equals negative 12. Divide this by 16. I apologize for squishing this down here. So if negative 12 divided by 16, we'll get that dy dt is, let's erase that, negative 3/4 feet per second. Here you go. Bang, there we go. All right, so I hope that helps. These are going to be challenging at first, but practice them. And myself too, I need to practice better explaining these, but just let me know, give me feedback. Hopefully it helps, but any feedback is appreciated. And then thanks for watching, and make sure you subscribe and tell all your friends, and I'll see you guys in the next video. Bye.